All right, dude, we are live. What's up, guys? This is Dem Keys, and dude, it's been a good day. It's been a great day. I've been busy doing a whole bunch of stuff with the Transformers library. I've been fiddling around with. Hold on, let me go back to the notebook. Here it is. I've been fiddling around with a bunch of Transformers related stuff. Well, basically, I've been fiddling around with Transformers, more specifically pipelines. Or is it pipeline? Hold on, let me just, I think it's just pipeline. This thing. I've been fiddling around with pipeline, and it's amazing, dude. It is great because you have like a list of tasks that you can give to pipelines or to pipeline. So you can create a pipeline and you can specify a task that you're trying to that you're creating this pipeline for. And then you can either specify a model to use in the pipeline, or if you don't specify a model, it's got a default model for each task. So it's going to use the default model. But you very much do have the option to customize the pipeline. You can specify first of all your own model, which can be any model from the transformer. What is it called? HuggingFace hub, I think. I don't know. Some a hub. Basically, you can specify models that have been hosted on Hugging Face. You can specify those in uh, in pipelines. Though it's worth noting, I think you can only specify the ones that have support for Hugging Face, or rather, I should say, it's kind of from the other side. I should say it. You can only use models that Hugging Face has implemented in pipelines. So models that have actually been implemented, models that there is an implementation for in transformers. You can only use those models. And usually there's an easy way to check that, which would be, hold on, let me go to, I want a way to search for the model. Yeah, here. I guess we can do it through this. Let's say segment. Okay, this is not what I was looking for. Let's try opening this up. And then in here we have, there was a way to get to the search, which I had it running in one of my other tabs. There was a search thing, basically. Okay, let's do this. Let's actually no. Let's say segment. I'm gonna search for segment. There it is. This is not what I was looking for. Let's try that again. Segment. There it is. This is the results I was looking for. I can zoom out so that even this filter thing shows up. So basically, you can, for each task, using this search, you can kind of filter out all the models that have been hosted on Hugging Face. You can filter them out by task, and then there's other options as well, which I haven't looked into them yet, but I'm on task. Actually, let's try libraries. Yeah, okay. So there's other filtering mechanisms as well. But let's say the task you are going for is image segmentation, right? So that's one of your filters. And then you can type in a model name. You can type in a name that's going to show up, or if you don't type any name, it's basically going to show you all the models that have anything to do with image segmentation. You could also do object detection, and it'll show you a bunch of models that have been hosted for that, and so on and so forth. There's a bunch of different tasks that pipeline supports. I haven't tried all of these tasks. I am kind of curious. I am kind of curious about whether all of these tasks work or if it's only some of them. Because in terms of text, we have, I'm not seeing sentiment analysis here. Is it somewhere else? Because sentiment analysis is also, it's also a task, right? But I'm not seeing it here. Maybe it comes under one of the other categories. Okay, anyways, so I've been playing around with this. I've been more importantly, I've been playing around with image segmentation. I messed around with object detection as well for a little bit, and it's kind of interesting, dude. Like, I mean, I've seen these models in use before. I've seen these models being used before, but I haven't used them myself. At least, not from code. I've used other people's ready-made demos. So it was kind of cool to do this myself. So I played around with what depth estimation and object detection and image segmentation. So with object detection, it creates a sort of bounding box that represents the detected object, right? That entire thing gets returned to you. Whereas with um, with image segmentation, it returns. So image segmentation technically also returns an image. It returns an image of like that exact shape. However, it's going to return multiple images, and each of those images is essentially a mask. Uh, it's a mask of what the classification is. I'm not explaining it very well. It's best to show it to you. We're gonna do that. I actually today's the goal for today's stream is to create some logic to iterate over an entire folder and pass each of the images in that folder. Hold on. Zenar, hello, welcome to the stream. Like the bounding boxes of the classification. In the case of object detection, yes, there are bounding boxes. In the case of image segmentation, it returns the entire image as a mask, but the mask is going to be specified by like black and white, and the white portion of the mask is basically what that image is supposed to, or rather what that classification is. So if you give it, let's say, an object. Oh, pixel mask for the areas segmented. Yes, exactly. It's a pixel mask that represents the specific things that have been classified in that image. So it can be actually I'm gonna pick a data set. The data set that I was using was human body pose estimation thing. I don't think I can show that on Twitch, so I'm not going to do that. I'm going to find another one, and we're going to use that. So image segmentation. I'm going to pick any data set here. What does this contain? A large scale fish data set. You know what? This is good. This is actually, yeah, this might be good because this will give a bunch of things. So okay, another very interesting thing is trying to find out, or well, trying out different models to see the different kinds of classifications that they can give you, because not all models are meant for the exact type of classification. Not all of them give you the exact Like not all of them are going to classify, you know, 100, 200, 300 different types of objects. I've seen models that are meant specifically for, I don't know, like buildings or something. And if you try and pass them humans or fruits or something, they're not going to give you anything useful. The one that I'm currently using is it's more general purpose, I believe, because I did find a bunch of things. I gave it, for example, a person standing in a room, and what it did is it created different segments. Yeah, I usually train one specific to the data I'm expecting. At some point, I'm gonna get to that as well. I want to try training I want to try training it using transformers, but then also building one myself once I have a better idea of how to build convolutional neural networks. But that's gonna be much later. Okay, for the time being, I need to. Okay, let's take a look at these. Let's take a look at these images. Okay, what kinds of files are these? Okay, regardless, I don't think I can view them. Building them from scratch is impressive. Lots of understanding required. Yeah, I've been super interested in building neural networks and just in general data science stuff. So far, I've learned how to build a feed forward neural network. What was I saying? Yeah, so far I've learned how to build a feed forward neural network, and there's a lot that I have to explore in that as well. So I don't want to move forward before. Also, thank you for the follow. Appreciate it. YOLO V8. Wait, no, hold on. You said something here. You said something before that. I just cross-train high performance general models. YOLO V8 with as many images as I can be bothered tagging. So there's, what was it called? I think it was called Supervision. Yeah, there was a framework called Supervision that has an implementation of YOLO V8 that I wanted to try out. I'll get to that at some point as well, because I've been seeing one of the devs of that framework posting a lot about it. It does a bunch of things, like from object detection to, I think it also does image segmentation. I'm not sure, but they were using it for a ton of different object detection related things. Even being able to use it on like video. So not just, there's always so many cool things to explore. Yes, and that is why I'm glad that something like Transformers exists, because it kind of creates an abstraction layer uh, to where you don't necessarily need to worry about the implementation of each of the models or what kinds of inputs they would be expecting, because to a certain extent it kind of standardizes all of that for you as well. You still have to worry about it to a certain extent, but like not nearly as much as if you would have been using each of these models by themselves. So I'm kind of glad, because like the amount of models that I've been able to test out just today alone has been crazy. It's I don't I think trying to test out each of these models individually, it would have taken me quite a bit of a setup. But yeah, okay. Uh, a large scale fish data set. So are these individual fishes? Can you explain that very briefly? Not familiar with Transformers. So Transformers is a library from Hugging Face, and it does a bunch of things. I myself am very much sorry to distract you so much. Nah, it's fine. I'm gonna get distracted regardless. Like as I'm doing this, I'm just gonna keep getting distracted in a bunch of different things. I'm gonna distract myself anyways. So like, you're good. It's fine. This is Transformers. At a very base level, it allows you to it it does like what I was mentioning earlier. It allows you to it creates a sort of abstraction layer for you to where you are able to specify a task, like let's say image segmentation in this case. Actually, I can kind of demo it right now. Hold on. Where's my notebook? Here. Okay. So let me just run this where I need the data set. I do not want to use the data set that I'm currently using because that's kind of TOS. Uh, just a second. Just a second. We'll find a decent data set. Something that can be segmented and we can kind of get chunks out of it. These are faces. Is it gonna like give facial structures? No, I'm not too sure how well that's gonna work. Cityscapes image pairs. You know what? This might work. This might work. Let's try. Let's open this up. See what the image is. Yes, this is gonna work. Hopefully it's gonna classify them properly, but even if it doesn't classify them, like even if it doesn't label them properly, at the very least, if it just creates the different segments, that's more than enough. So this is the, hold on. Give me a second. I'm just gonna do something here. So I'm going to use this data set. I'm going to add this as an input here. Okay, that is good. Great. All right, so the data set has been added, and now I can pick, let's say, I don't remember which image it was, 10. Let's say 10. Okay, I'll copy this, and let's create a new cell here. Oh God, did something show up? No, okay, just nothing happened. It's all good. You know what I should do? I should clear all the outputs. All right. So let's create a new code cell. And I also need to run, I think I need to run this. Yes, I need to run this to import all of the modules that are necessary. Is it done? I think it's done. Is it done? I think it's done. Yeah, it's done. Okay, so let's say image segmentation task. Okay, we can create a pipeline object, which is pipeline is part of the Transformers library. In here, you can specify the task. So for us, it's going to be image segmentation. And the model that I'm using, I don't remember the name, so I'm just going to scroll back up. Where is it? I think it was this one. I think it was this one, yeah. This is the one. Okay, so model equals, actually, let's do model underscore name equals this. So this is a model by Facebook. We're going to pass in the model name here, and I want this to run on the GPU. I want this to use the GPU, so I'm going to also specify the device. Okay, so this is our pipeline object. Oh yeah, so now now we just need to call this as a function. And when you're calling it as a function, you pass in the path for your image. Let's also, yeah, let's do img path equals, actually, I think I need to copy this again and paste. So that's our image path. We're just going to pass in, so this is our prediction variable. We're going to pass in the image. And for the time being, I'm just going to print out everything that gets well, classified or predicted in this case. Give it a second. It's just going to do a bunch of downloading. And right, so this doesn't really look great. Let me print it out. Where was I? Oh, yes. Okay. So for I in predictions, we print out I. So that looks a tiny bit more neat. These are the things that were classified in that image. For each classification, it returns a dictionary, and that dictionary contains a bunch of information. First of all, actually, the first thing is score, but then you also have the label, as in what the thing has been classified as, and you also have the mask. And it's great. It's super convenient. It's super convenient that the mask is the same size as the image, because in case if you want to do something like layering multiple masks together to sort of create a transparent version of the entire image, but like, how do I say this? Let's say you want to create an entire mask of all of the segments. My favorite model of car, label underscore one. Yeah, yeah. I need to find out what exactly that's pointing towards, because I'm not sure what that's like. I haven't had a chance to look at what exactly all the labels are. That's okay. So I do want to explore certain things in the Transformers library as well. Like, for example, this thing. Like, let's say we plug in a model into pipelines, and it gets, how do I say this? Let's say we plug a model into pipeline. How can we get all the labels that that model is meant to what am I? I'm losing my train of thought. Yeah, how can we list all the model? How can we list all the labels that the model can possibly predict, can possibly classify? Can it spit out the image that the masks? No. Can it spit out the image with the masks overlaid? Not with the mask overlaid, but it gives you the mask itself, and then you can write some code to overlay it yourself. Let me show you. So each of these things here are separate classifications. It's that one image that has been split up into multiple chunks. Yeah, usually. Wait, hold on. What was I saying? Yes. So there's a separate dictionary per classification, and for each of these classifications, you get a mask. That mask is going to be more or less a grayscale image. Let me print out each of these. So I'd written some logic for this earlier. We're just gonna redo that. What was it? So we want, if the length is greater than or equal to, what is it, 1? Yeah, because we wanna display the we want to display the original image as well. So if it's greater than 1, then we create all of this, and we want to create how many subplots in total? I think it's supposed to be plus 1. I think it's supposed to be plus 1. Yeah, so we do length of this plus, does that make sense? Yeah, yeah, yeah. And what else? Oh yeah, I need to specify a figure size as well, just so the thing is big enough. Um, okay. Then, yeah, I think after that we just run this loop. So for this in enumerate uh, prediction, we show an image. Uh, oh, yes. Okay. So we do I mask, and then we also specify a color map here, which would be gray. There was something more. Oh yeah. At the end, there's supposed to be this minus, I think. No, no, it's supposed to be exactly this. And here we want to show the image. I don't think I ever created the image itself. Yeah, yeah, we should do that. We should do that. Okay, image equals image dot open image path. All right, so that's going to be our image, our original image, and we're going to display that. And I think we should be good to go. So now we can run this, and assuming there's no errors, which there might be errors. Yes, there are. I missed an S in subplots, which is here. All right, what's the next issue? Okay, so gray with an A, not an E. All right. Yeah, there it is. So I'm not sure how well this is showing up because there's, yeah, classic spelling stuff. I have this issue so often that I can just look at the thing and be like, yeah, okay, I missed that. I missed that. But yeah, this is one example of it. Let's try another. Uh it is, you're right. It is small. I need to make it bigger. Okay, you know what I could do? I could I could put one on each row so that it would um we could do it in this way. Though if I did it in that way, if I had multiple rows, then how would the axis be? Um, would it be like this? I think I think it would be like this. Would that work? No, no, that's not. How do you it would be cool to run convex hull on the pixels of each classification to create a vectorized overlay of the segments. That gives me something to that gives me something to do research on. Convex hull. Give me a second. Let me just write that down. Though whatever you are talking about, guessing there might be, to a certain extent, there might be a way to do that. Hold on. It would be cool to run a convex hull on the pixels of each classification to create a vectorized overlay of the segments. It's a bounding algorithm, but it's probably built into the software. Okay, I guess I'll learn about it later on. Yeah, yeah. That gives me something to do research on. What I was planning on doing today. Hold on. Did I do the thing right? I think I. You know what? Wait. I'm curious about this. So let's say figure, axis. We're gonna do subplots because I'm gonna be using this later on. That's why I'm curious about how we would go about doing this. Uh, let's say 0, 0 dot plot. I'm not explaining this well. I thought you might know what it is. I don't. I'm very much a beginner in deep learning. And wait, I don't know. I don't know if you're stuck in an ad right now. So I'm gonna stop talking for 30 seconds, and I'm gonna take a hydration break. Okay, welcome back. So, no, I have no idea what you're talking about, but I'm kind of glad that you mentioned it because that gave me something to do research on. Because I'm always looking to learn stuff. Who knows? Maybe one of the future streams is going to be me learning that, assuming it's like a big enough topic that it takes me some time to understand. But yeah, it's all good. So let's try plotting this, and there is the issue. So I don't remember how we are supposed to. Is it supposed to be like this? No. How are we meant to do something with multiple rows and columns? Like what was the wait, let me just Google this. Matplotlib, multiple rows and columns. Creating multiple subplots using PLT subplots. Okay. All right. Uh, so there's a figure with just one subplot. I do geospatial development and often have to create vector representations of pixels in images, so I think about things from that perspective. Interesting. That's really interesting. Tell me more about uh, geospatial development, because I'm still very much a beginner in actually in a lot of like so data science, machine learning, and deep learning. I'm still very much a beginner in all of it, and I'm learning as I go. So there's always something new for me to learn. But that's interesting. So in subplots, if I specify a row, okay, it says that the subplots get divided, they get split up into, though that's not going to be very dynamic, is it? That's not going to be dynamic. If I have to specify the tuples manually, then Oh, there it is. Okay. Hold up. Hold up. So we have. Okay, this should be working. Okay. What did you say? Part of the field of geospatial information science. I do digital mapping basically. Spend lots of time using basic ish data science to automate and improve mapping work. That is interesting. Now that is super interesting. I don't think I've ever Yeah, I don't think I've ever spoken to anyone who does that kind of work. I think the closest that I got to doing something like that was when I had a list of clients for a business, and I was trying to create a heat map. I was trying to create a heat map of the clients for a specific location, but like I kind of pushed that aside because I got busy with other stuff. My only idea was like, I mean, the whole how what am I trying to say? The thing that I had to do was simple. I just had to, because I had the longitude and latitude. I just had to map that onto an image. It wasn't necessarily something complicated. It's just that I didn't at the time. I didn't know how to do it, and I got kind of busy. But that's the closest that I've come. What you are doing is probably much more complex. I've never heard of what did you call it? Uh, geospatial something. Geospatial information science. Yeah, I've never heard of that. But hell yeah, dude. That's cool. I'm currently working on web scraping weather data from from weather station outputs and linking them into a live updating web map. GIS is the general term for it. Interesting. Okay, so this is saying too many indices. Too many indices for. All right. Now let's do some subplots. Hell yeah. Hell yeah. I'm still trying to figure out what I'm doing wrong here because the code examples are showing that if you do plt.subplots, then like if you specify the rows and columns in this way, then you should be able to access this as like a multi-dimensional array. But when I do this, then I'm getting an error. AX is a one-dimensional, but it shouldn't be. Yeah, in this case, it's not supposed to be one-dimensional. Um, could it be because of this? Oh, okay. So I think I noticed this issue even when I was doing it in this way. Yeah, yeah. I think it kind of just squashes it to like a single thing. If so, if either the row, well, no, if the column is one and you have multiple rows, I think it's expecting you to access it in this way. Yeah, there you go. It's expecting you to access it in this way. 1 1 is a point, not a vector. In this case, it's not. So with subplots, when you call subplots, then the first thing is the rows, the number of rows, and the second is the number of columns. You don't have to pass it in as like a tuple or something. Um, but yeah, this I noticed this issue earlier as well when I had one row and one column. So in that case, like if you specify it with one row and one column, it's not going to be a, even though you're kind of specifying like a multi-dimensional thing, right? So you're expecting to be able to access it in that way, or at the very least access it as a list. But no, it kind of squashes it down and then you have to access it like this. So I think when you specify one column but multiple rows, it's kind of squashing it down to just a list. And that's what was causing the confusion. Okay, hold up. So if that is the case, I don't think I need to do this. This just occurred to me. I don't think I need to do the, what do you call it? I don't think I need to do the multi-dimensional thing or even the jagged array thing that I was trying to do here. I just need to, I just needed to switch the rows and columns, and the rest should just be the same. That makes sense. It's not multi-dimensional if it doesn't need to be. Yeah, I had no idea that it actually does that. So that caused a bit of confusion for me. All right, so here it is. These are, so we have the car, we have two cars, and then two labels and road. So this is car, and then this is some kind of label for something. We're going to change the image because this doesn't really tell us like a whole lot. Oh, wait a second. Okay, hold up. Maybe I need to change this. Um, are all the images like this? What about test? Oh, well, okay, it's not test. Right, this is giving like both the original and the segmented thing. Let me pick some other data set. Um, people clothing segmentation. Okay, assuming the people are clothed. Um, because that was my issue with the body estimation thing. Right, let's take a look at one would hope they're clothed. Yes. You know what? Yes. Okay. This gives us, so the keeping the clothing aside, like the clothing is definitely important as well. But like aside from just the clothing, there's a bunch of things going on in the background, and we need that because that's what the model is going to be segmenting essentially. Um, give me a second. All right, let's just copy this and bring it here. And okay. All right. So let the thing get added, and then I can hopefully if the images are of like a if the images are not rectangular, then maybe I can go back to doing the horizontal kind of layout. Okay, so we have, what was it? People clothing. There it is. JPEG images, and let's pick this image. Let's see what shows up if we try to segment this. Where was I? Yeah, here. So this is our image path. Let's run this. Oh, you know what? This is good. This is good. These are kind of 16 by 9. Actually, is that 16 by? No, these are kind of 9 by 16 ratio kind of things. So we can we can switch this back. So now it just shows up in one line. All right, great. So let's see what all we got. So first of all, we have the human, right? And then there's the background stuff, and then there's something that got picked up here, and something that got picked up here. I think it picked up the human being here as well. Let's see if it actually recognizes the human being. And then in the background, there's something else that's basically just the environment. So this just got classified as label, and then this is person. This says door stuff, which is the stuff that's whatever is here. Then there's label, and then there's the person. Hell yeah. Okay. Let's try. Uh okay, so there's 02 all the way up to 10, 20. Right, so we have a couple. What was I doing? Yeah, yeah. So let's change this to 2. What's this image? Okay, this is interesting. So we have a couple of things here, right? With this image, actually, I wonder if I should additionally print the image at the bottom. So let's also do plt.imshow. What is it? Just img. That did not print out. Wait, why didn't that print out? It's done pretty well. Yeah, so I've noticed this with I've been kind of trying to see how good the models are at segmenting more I guess dense images, densely populated images that have a bunch of things going on in them. And yeah, these models they seem to do a pretty good job. Something I want to test out is uh, after I learn how to fine tune models, then I want to see I want to see if I'm able to how do I say this? I want to see if I'm able to train or fine tune a model on a specific set of data, or rather fine tune a model on data such that it's able to segment specific types of images. Yeah, I guess that's the best way to put it. And that's kind of one of the ideas with fine tuning models, right? It's like you're not tuning the model from scratch, because obviously these models are trained on like massive amounts of data, and there's no way that I'm going to be able to train it from scratch without massive amounts of compute power. So fine tuning is the next best thing. And fortunately, Transformers does allow you to fine tune as well. I haven't gotten to the fine tuning part yet because I just got busy with playing around with the various tasks that are supported out of the box. Today was mostly depth estimation, object detection, and image segmentation. And I just remembered from depth estimation, there was a model that did both depth estimation and generating normal maps. You could give it any scene, and not only will it give you a depth map, it'll also give you a normal map for that. I don't think it's the same model necessarily, but it was the same framework that you could use to generate both of these things. At some point, I want to try generating a normal map, not just generating the normal map, but then also trying to apply lighting to that image, or rather, trying to use that normal map to calculate lighting for the image. Because I've done this in a 3D context, or I should say in a game engine context. I've done lighting calculations in a graphics programming context, but I haven't really done it in in the AI context. I've never had to generate a normal map. And I mean, I don't think I'm going to be doing the lighting calculations myself. I'm probably just going to look for the function because pretty much all of it is going to be in pixel space. Um, Even the normal maps that are being generated, they're being generated based on the pixel uh, the pixel space values. So any lighting that I'm doing it in the pixel space. Though I think, yeah, no, I'm gonna have to go back to learning how to do those calculations. That's gonna be a bit of a headache. I'll just look for somebody's implementation on it if someone has done it. Or you know what? I mean, I could try doing like a very basic thing. Like I could try applying a very basic what was it called? What was it called? Um, there was a name for it. It was a diffuse model, a very simple diffuse model that it just took a couple of things into account. It took um, what all did it take into account? Dude, okay, hold on. I need to look this up. There were a couple of things. There was emission. There was, if you wanted, there could have been specular. Um, and then there was your diffuse lighting, your main diffuse lighting. And then there was a way to introduce normal maps into that. Man, I don't remember. I did this a while back. Okay, yeah. At some point later, I wanna do that. Yeah, yeah. Okay. Now, why is this image not displaying a second time? Am I missing something here? I don't think I am. Let's try doing just plt.plot. See if that shows up. Yeah, that's not showing up either. Though, if I ran this same thing again, this would show up. I've done this, I did this earlier. No, that's not showing up either. Okay, I'm definitely missing something. Oh, wait, no. Yeah, I think that's what I was missing. Yeah, there it is. Okay, so I guess if I'm using PLT, it might be trying to use one of these older ones. Let's test that out. Um, let's create a second image here, img02, and let's make this image 1, and then let's load image.open img02 path. Okay, great. We can get rid of this, and in here you pass in this. Yeah, yeah, that's what it's doing. So it is using, so because Matplotlib has it has this concept of like it has a way of storing the currently used axes, like the thing that's currently being drawn on. It stores that, and there's a way to change it as well, but like that's its internal state that it stores, and that's what it's using here. So I guess what I could do is I could just create a new thing, plt.subplots, and I'll just not specify anything, and then I can do this. Okay, great. So now that we have this, we have a bigger representation, and I can pass in img, just regular img. Okay. What else? Yeah, we can change the image. We can move on to a different image and see how that gets segmented. Right. So this is interesting. So we have the sky here, and we have some kind of fence behind this person, and then we have the person as well. Um, it definitely segments the ground and the sky pretty well in a lot of cases that I've seen. There was one image that I had of somebody standing on the beach, and in their background there was just open water, and there was the sky as well, and a bunch of that stuff got segmented properly. Okay, let's see what this is classifying. So it's not giving proper labels, but it has so it's it's segmented stuff, but it doesn't necessarily know what it's segmented. It knows that the person was segmented, and it knows that, or it's assuming that there's a roof over here. It's assuming that this is a roof, which I think it might be. I don't know. And there's a book apparently, which is what, fifth one, I think. This. Oh yeah, okay. It caught the book. Look at that. All right, let's try another one. Oh, you know what I wanted to do? That was actually the plan for today's stream. First of all, redoing the image segmentation, but I also wanted to write some simple logic to iterate over all the images in a folder, or maybe iterate over 5 or 10 or something images in a folder, and run those images through the image segmentation model, and then display all of their results. Display all of their results in this manner. The thing is, I need I need a way to, okay, before that, I think it would be much better. So I'm dividing this up, right? I want to layer them on top of each other. I want to layer them on top of each other. Now, to layer them, okay, so we have these images already, right? We have these masks. So I can get the images. So let's say img array, I guess, equals um what was it? X. Yeah, X. No, actually it's the mask. Yeah. For X in range len prediction. And then let's just print out this array. Okay, so those are all our images. All right. Now I mean, each of these are already images, right? If I access any one of them, I'm getting the image. And if I do plt.imshow and I pass in this, there you go. I just need to give it a color map, and then it's going to be a, what do you call it? It's going to be a grayscale image. Okay, so here's what I can do. Because these are all, okay, wait. I'm wondering if any of the segments could accidentally overlay on top of each other, or kind of kind of intersect each other. Like I wonder if that's a possibility. or rather, I should say, I wonder if any of the segments could occlude one another. I don't think I don't think that should happen though, because it seems like, I mean, looking at these pieces, um, like it kind of seems like you could put these pieces together like a puzzle, and it would form the original image. So like this thing, for example, you could put it on top here, and then you can bring this thing and put it, there, and then even this thing, if you try to fit it in here, it's not going to cross this person. It's gonna go around the person, and then even this, it's going around the hair. So I think it kind of fits together as like pieces of a puzzle. Um, I need to look into what methods Pillow has to sort of create a composite of like these multiple images. So actually, okay, speaking of composite, there is a composite method, but I guess what I'm trying to do here is, wait, why am I trying to composite it? Why not just multiply them? Yeah, what are the values? Let me read out uh, or try to read out the data. How do you access the data of? Is it like this? Now, how do you read the data of a pillow image? Read PIL um, image bytes. Oh yeah, I think I remember why I was doing that. So okay, if we consider, so these are grayscale images, right? Um, more specifically, just black and white images. If we consider black to be 0 and white to be 1, or white to be even 255 for that matter, but let's consider it 1, right? We could multiply all of these images together and get the final image, right? So even if I multiply these images by a color first, just to assign them a random color, and then multiply that with the next image. Should I multiply? No, I don't think I should multiply. I should multiply to give it a color. But when I'm adding it to the next thing, I think I should just add, because the assumption is that the other thing is 0. Like, yeah, the assumption is that the black over here is 0. And so if you add something on top of that, it's not really gonna like be a blown out value, or like a blown up value. Um, it's gonna be the right color that you're looking for. It's not gonna be like a, what's the word I'm looking for? It's not gonna be like a very high value that's gonna cause the color to look just white. Okay, open PIL image from byte file, convert PIL image to byte array. I guess that's my best option, isn't it? Convert the PIL image to a NumPy array and then do whatever calculation I need to, and then convert that back to a PIL image, and then, yeah. Wait, image had a thing for from array. Does image also have a thing for to array? Um, Give me a second. I'm reading something on another screen. This is somebody's trying to do something else. They're trying to get an image from an array. I think you can simply call the toBytes method, and from there convert it to an array. Okay, let's try that. All right, that is bytes. That's a bytes-like object. Can I create a NumPy array out of a bytes-like object? Let's try that. A, B, C. Let's not print that for now. Okay, so is it still a NumPy array? Yes, it is. Okay. All right. Um, is that gonna work though? I don't know if that's gonna work. This also seems like a pretty horrible way of doing it. I think there's probably a more better way. How to get image from bytes, convert image to byte array. Maybe it's not bytes that I'm looking for. I could do, um, hold on. I could do PIL image to NumPy array. NumPy array grayscale. Right, and then I can multiply that with whatever color I want to. Though it's a grayscale image. If it's a grayscale image, it's probably not going to be RGB values. So I guess the first thing I should do is convert this to RGB. But the problem is the image is in a mode called L. I haven't had the time to look into that, but like that's what's allowing us to do this grayscale thing. And there isn't like a straightforward conversion between that and RGB. Though what I could do is I could no, there has to be a way, like if not a straightforward way, then maybe a not so elegant way of doing it. But there has to be a way of doing it. Image from array. Okay. It seems to only work properly with an array of integers between 0 and 255. That makes sense. Okay. I use so and so for this. All right. Cool. So this is telling us how to generate an image from a NumPy array. I'm trying to generate a NumPy array out of an image. So I want to read the image first and then pull the values from that. There is a way to just get the bytes, and then like if I can read, yeah, let me try that. Um, PIL image, because I remember reading about something in Pillow where it doesn't necessarily load the data. It loads the image itself, but it doesn't really load the data until you do specific things. And there was a performance related reason for that, and that's one of the reasons why why Pillow is able to handle like even massive images. It's because it doesn't immediately load all of the data. It only loads some of the data of the image, and that's mostly the metadata. Pill image to NumPy array. Okay. Yeah, this is the okay, NumPy array pic.getData. All right, so let's try get data. There was also set data, and that's how we would set the pixels. This was all a while back, so I don't remember. But okay, let's try printing that out. That did not print it out. What does get data return? Hold up. Um, img test equals image open something. So the assumption here is that it's going to return an image. Okay. Image test dot get data. Okay. It returns the contents of this image as a sequence object containing pixel values. The sequence object is, oh, the sequence object is flattened. So the values for line 1 follow directly after the value. Yeah, okay. So I'm going to need to, I could just reshape the array. I could do that. Yeah, I could just reshape the array to the size of the image. What is the size of the image? Also, this is not returning anything. Why is that? Like, what am I supposed to be? You're not saying how exactly put data is not behaving. I'm assuming you're doing so and so. This is because put data expects a sequence of tuples, and you're giving it a numpy array, which is this. Okay, all right. Proper way to convert between numpy. Okay, that's a link leading to somewhere else. Never mind that. Although the resulting array is different from yours, 3D array or so and so, so and so. Uh, I need to keep looking. Converting a pill image to a numpy array. The result looks garbled or sheared. Okay, what did this person do? Right, let's try getting some basic data of this thing. Okay, let's try, what is it? Shape. Oh, what did I just type? Shape. Size. Size. Okay, so it's 550 by 825, and pretty much all of the masks are going to be that size. Um, okay, all right. Let's try storing this somewhere. So let's say img data equals that. And then let's try printing out img data. Just says object. What is get data is returning something. Get data is returning something because this is saying imaging core object. Run through the image matrix, indexing the pixels, so and so. Okay, okay, okay. Pill image to array and back. All right, let's try that. Not entirely sure what you're trying to achieve, but if you just want to transform the image to a numpy array and back, the following works. From array, okay. This says from array. Okay. What about to array? Array image save. If you just want to transform an image to a numpy array and back, then this works. Where in this code are you transforming the image to a numpy array? Array image save, numpy array, so and so. Yeah, nope. I don't think. Yeah, that's not doing it. Okay. Can I just pass in the pill image? Is that going to work? Let's try. A equals np dot array img array. And then let's try printing A. Wow. Okay. So that worked. Great. I wish I knew that. Okay, so this has what, 550. Why is it 9 values? It's 550 rows, and wait, am I reading that right? Or is it supposed to be 9 rows? Because then it would be 9 rows and 825. No, no, that doesn't. What did I? Oh, yeah, that's my fault. Okay, it's because there's nine. Uh, there's nine. There's 9 masks. Really? That last thing had 9 masks. Oh yeah, it did. Okay. Yeah, yeah, yeah. That was my fault. Okay, so cool. So this is our grayscale image, right? We can then multiply the. Actually, okay. Here, I think this is where the problem arises, right? We need to construct. We need to. So okay. Since this is now a two-dimensional array, I should be able to access the thing like that, right? So we need to be able to convert each of these to 3 values. So this is right now just one value. We need to be able to convert this to RGB. And like I could write some kind of list comprehension kind of thing for that. Uh, I could do that. I could do that. Okay, let's try. So let's say array, and in here we pass in the list. How how am I going about this? So I can just duplicate the thing, right? So now it's going to become a three-dimensional array. So it's going to be whatever, 550 by 825 by 3, right? So it's trying to look at it from a two-dimensional perspective. It's 550 rows. Each row has 825 columns. Does that make sense? No. This was a this was like a portrait style image. Does that make sense? No, it's supposed to be 825 rows. Why did the thing get flipped? Wait, let's try printing. Okay, let's just print out the shape again. Oh, it didn't get flipped. I confused myself. Okay. All right. So for each of these, so yeah, okay. So we're gonna have 825 rows, and in each row we're gonna have 550 cells. So it's gonna be 550 columns, and then each of those cells is gonna have a list of 3 items. That's what we are trying to do. Okay, so let's start with the list of 3 items. No, how do we make this into? I'm trying to think of a way. I'm trying to think of a way. No, I don't think I can use reshape for that because we have to generate the data, right? The data doesn't exist right now. The data that does exist is like single values, and we're trying to make each of those values into 3 values. Um, yeah. Um, okay. We could. So what are we trying to do here? We're trying to create, let's say, okay, so let's say C equals this. We are trying to create, so this is one row, right? And the row has each of these cells, and then each cell is supposed to have this. This is what we are trying to create. Wait, is it? No, no, no. There's something wrong here. Uh, okay, let's make this a NumPy array and then get the shape. I feel like I'm missing something here. Okay, so it is one row with three columns, and then each column has a three-dimensional thing in it. That's kind of what we are trying to do, right? Okay, so if I try to access the shape, the shape given here, so 0 is going to be 825. Right, that is our number of rows. I'm trying to get the number of columns. Okay, all right. Um, so we read out uh, a, let's say x, and then, yeah, we just duplicate that. For x in range, length a dot shape 1. Okay, so that is for one. That's not for one cell. No, that's for one column. No, that's for one row. That is for one row, and that's each of the cells in the row. That's each of the columns in the row. So then we can do another for x in. Should I change the thing to something else? Okay, wait. In range length. Wait, let's do this. Just so it just so it's a little less confusing. Length a dot shape 0. So that's our number of rows. And after that, our shape for B should be three-dimensional. Assuming this list comprehension worked, let's change the way that we are accessing that. Object of type length, type int, has no length. Oh, yeah, that's true. Why am I doing length? Uh, okay. And there. All right, let's try running this. Okay, so the thing ran, and all right, so I made a mistake in the logic somewhere, because now we have a four-dimensional array. This is not a three-dimensional array. Yeah, I definitely missed something here because, oh, um, yes, I think I got it. But then how? So I'm trying to iterate over. Wait, let's just, yeah, okay. Still have that issue. I'm trying to iterate over. I think the issue is in the way that I'm accessing this. For the sake of an example, we're just going to try doing this. Yeah, it's the issue is in the way that I'm accessing the values. Now, how am I supposed to go about accessing the values? I have y and I have x, right? X is supposed to be our column and y is supposed to be the row. So I should probably do it in this way, I think. I'm just having a hard time visualizing the thing, but like, okay, we'll get there. Okay, so now that we have this, let's try converting this into an image. So let's say b image equals image dot from array. We'll pass in b, and I think we can give it a mode as well, right? Mode RGB. Okay, assuming that works, we can then print out b image. Okay, something went wrong. Unrecognized image mode. Okay, let me look up the documentation for pill image from array. Okay, in the image module, there's from, what was it? From array. All right, what are the valid modes that you can give it? Optional mode to use when reading the object will be determined from type if none. All right, let's take a look at the valid modes. There's L, which is 8-bit pixels grayscale. There's P, which is 8-bit pixels mapped to any other mode using a color palette. Oh, I think it's case sensitive. I think that's the issue. Okay. I guess it works. All right. Okay. Cool. Now, all right, let's try something here. So, assuming it's 1, not 255, assuming it's 1, let's say we multiply it by, I don't know. Oh, you know what? I could get a max of this. I could just print out b dot, or do I have to do that per? Hold on. Let's see if it gives something. Oh, the max is 255. It's not 1. The max is 255. Okay. Um, how do we go about this? Okay, so we could then subtract. Yeah, we could subtract the value. So let's try to make the entire thing red. So let's do 255, 255. So that should be a red image. Oh God, that is not a red image. Um, how did it end up with this kind of? Okay, let's try this. Because the idea behind what I was trying to do was I was just trying to remove the color channels for, okay, actually, real quick, there's going to be an ad playing in like 10 seconds. So I'm going to start the ad break right now, and I'll see you guys in 30 seconds. All right, welcome back. So, the idea behind this was that I was trying to remove each, I was trying to remove each, like, from RGB, I was trying to remove, or rather reduce the values for each of them. So if it's white, then I'm assuming it's going to be 255, 255, 255, right? Did it get the mask right? I think it got the mask right. Yeah, I think it got the mask right. Um, what if, what if I, hold up. I need to test something. So let's say I create this. Okay, let's do a multi-dimensional array, 1, 2, 3, 1 or 4, 5, 6, and let's do it like that. Okay, so then let's multiply this by 2. C equals C multiplied by 2, and then let's try printing this. So the idea with NumPy is that like these kinds of operations, you're supposed to be able to do them in not just an easy way, but a more performant, a more performance friendly way, as opposed to if you were doing it, without NumPy. Um, okay, this works, right? Great. So what if I did b equals b divided by 255? That should give us 1, right? And then I multiply. No, see that, okay, there we run into an issue because that's going to apply it to every single cell. It's not going to apply it to like the RGB values. Yeah, it's not going to apply it to the RGB value. If I wanted to apply to the RGB value, what's an easier way to remap this to a 0 to 1? Because if the thing was 0 to 1, it would be a little easier. Though I'm not able to understand why. I'm not able to understand why this would be an issue. Like, this is supposed to be R, right? And then this is supposed to be G, and this is supposed to be B. So if I remove, let's say, G, if I make G 0, oh, I'm not making G 0. I think, oh, yeah, I'm not making G 0 because like values that are 0 are going to go into the negatives and then, oh, I need to find a way to clamp the value. Man, this is becoming a little more complicated than I was expecting. Yeah, how do I want to go about this? Oh, I could try something. Instead of doing it the math way, what if I do it in like a way that just replaces? Because this is not exactly a grayscale image. It's actually a black and white image, right? So it's the values are either going to be 0 or 255. So since I know that it's 255, what if I, though it's not just 255, it's okay. Uh, we are gonna, because I cannot think of a more NumPy like way of doing it. I'll probably figure it out after stream. But for the time being, let's do for I in um, range np. No, not np. What is it? B dot shape, B dot shape 0, and then for j uh, in shape 1, we want to access this row and this column and set its value to be this. Is that going to work? I think that should work. I think that should work. Okay, it worked. Yeah, I need to add a check here. If this is not equal to 0, then this is a horrible way of doing it, but we are doing it this way. Okay, there's an error. The truth value of an array with more than one element is ambiguous. Use a dot any or a dot all. Okay, okay. So I think they're saying to say if a dot all uh wait a second. So let's create a new thing here. Np dot array and that. And then if c dot all is all not a thing, why is this not working? It's a thing. All right, dude. Let's try that. Okay, let me just Google this. numpy all. Oh, you know what I could do? NumPy change all values in array based on condition, replacing NumPy elements if condition is met. Yeah, there was a thing in pandas to do that. I remember that. Um, okay, so this is leading to indexing with Boolean arrays, which is basically how I had done it in pandas using Boolean arrays. Okay, let's try something here. Wait, what? How would I get? So something I could do is um I could get one Boolean value per. Dude, it would have been so much easier if I could have just. Oh, uh, wait, something just occurred to me. I was subtracting the value from 255. What if no, I was subtracting 255 from the value. What if I subtract the value from 255 instead? So let's remove this. So let's make the image magenta. I think this might work. Let's just comment all this out. Nope, that did not work. Yeah, that did not work. Why didn't that work? Uh, Pillow modes do not always correspond to NumPy D types. Pillow modes only offer 1-bit pixels, 8-bit pixels, 32-bit signed integer pixels, and 32-bit floating point pixels. Okay, all right. Let's set a D type for this to NumPy uint 8. Okay, okay. So it worked to a certain extent. Something happened here and it worked. I need to figure out um, why did the black become green? So I understand why the white became magenta. Why did the black become green? Oh, it's because 255. My God, dude. Yeah, that's why it became green because I did 255 minus the value. So it's supposed to be, so if the value is already white. Okay, you know what? I'm just gonna do it this way. Oh, yeah. I was supposed to learn how to use all. How am I supposed to use test whether all array elements along a given axis evaluate to true. So in this case, I want axis 1. Evaluate to true. So shouldn't I then also specify, oh, all is supposed to be for a Boolean array. Yeah, yeah, no, I don't think I should be doing this. Let's just do it in this uh probably horribly performing way. Let's check. This is gonna look ugly as hell, but if it works, it works. If this is equal to, no, this. So if this is equal to 0 and this is equal to 0 and this is equal to 0, does that work or is there some error? Oh, I think I was supposed to do not equal to 0. Actually, then I should be checking it in this way instead. I'm sure after I finish the stream, I'm gonna come up with the idea. Like suddenly it'll occur to me that, oh shit, yeah, I could have done this instead. But right now it's just not occurring. Okay, so we have something here with which we can uh, hold up. Yeah, okay. So what I could do here is I could create a numpy. I could create a numpy array, a random numpy array. So np.random.randint between 0 and 255, and the size, is it? Yeah, the size would be what is it? 1 by 3. Let's just test and see if that works. Yes. Oh God. Okay, no, hold up. We need to generate the color once. I generated the color once per pixel, and that's just a whole lot of noise there. So let's say color. Yeah, there it is. So now we have different colors for this. Dude, there has to be a better way. There has to be a much better way to do this. Um, I'm sure Pillow might have something for this. I'm pretty sure I don't need to go down to the NumPy level to do this. I need to check if Pillow has something for this. Because Pillow is essentially an image manipulation library. It should have something that allows you to like substitute colors or actually I also need to check. So one of the reasons I was doing it in this way was because I couldn't, in the limited amount of time that I did research, I couldn't find a straightforward way of converting an image that's in L mode to an image that's in RGB mode. I need to look further into that. I need to see if there's a way to, because like L mode is one color. Uh, there's no multiple channels, but RGB has three channels, right? So it's three colors. Or well, not three colors. It's three channels, so it's three values, and L is one value per pixel. Okay, now we have this. Are we able to just add images together? Yeah, let's look into that because there was a thing called composite or something like that. What is it? Image, um, add mask, I guess. No, what did I pillow. Pillow image add mask. Is it possible to mask an image in Python imaging library? Okay, image.composite method can do what you want. The first image should be a constant value representing the masked off areas, and the second image should be the original image. The third is the mask. The third. All right, so we have the original image. Let's print out the original image. We can also get rid of this because this is super slow. Oh, I think was one of my issues with composite was the fact that the image wasn't RGB. Yeah, I think that was one of my issues. Okay, so now that we have image here, I guess I can comment this out. Now that we have image, I guess I can do image.composite. There's alpha composite. What about regular composite? Okay, so we have image one, image two. Image one is the first image. Image two is the second image, which must have the same mode and size as the first image. That's what my problem was. And mask is a mask image. Fuck me. I didn't think about it in terms of a mask. Okay. 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 So here's what I could do. I could use um I could use A as the mask. So mask equals A. Image one. I need to create a color image. So let's say green image equals um, image dot from array. What is it expecting? Just a regular object? I think it can take a numpy array, right? In the case of numpy, be aware that pillow modes do not always correspond to numpy d types. Pillow modes only offer so and so. Okay, yeah, okay, that's fine. Right, let's do that. Let's do numpy array. Though I don't think I need to do numpy array. No, actually, I think I need to do numpy array. That way I can avoid. No, can I avoid it? I don't think I can avoid it. There was a way to do. Hold on. there was a specific way to do so. NumPy array with specific value. What is it? NumPy.full. No, I don't think full is what I'm. Is it? Is it? Am I looking for a full? Let's try this out. Okay, so np.full shape. So we are looking for 2 rows and 3 columns, and then the value, fill value, we can do 1, 2, and 3. I want to see what this fills it with. There's an error. Oh, composite. Okay. Yeah, that's my fault. That did not do what I was hoping it would do. What about now? Yep, there's an issue. So it's filling single values. What about there was a way to do this. Give me a second. I'm just looking this up. Was it arrange? I think it might have been arrange maybe. Give me a second. I'm just looking this up. NumPy.empty. Okay. Okay. Okay, dude. Uh, right. I'm not able to remember what the thing was supposed to be, so I think I'll just use list comprehension. So we want to do what? 1, 2, 3 for x in range, let's say 3. Right? And then this is for x in range 2. All right, so that does exactly what I'm expecting. Okay, great. So the green image is going to be NumPy array, and it's going to be, because it's green, so 2550 for x in range. Actually, I could do a random color. I could do a random color. I could generate random colors for each. Okay, wait. Yeah, we can get into that later. We can get into the scaling thing later. For now, just what is it? A dot shape. So this is our column number. right? And then this for x in range a dot shape 0. So this is our green image. Okay, assuming I've done this right, let's print out the shape of green image. No, don't print out the whole green image. Just print out the shape. Uh, there seems to be an issue somewhere. Okay, let's get rid of this for now. Okay, all right, great. So we have our green image. I can change the name to green mask. No, it's green image. It's not. This is not the mask. I just realized that this is not the mask. Uh, now, so let's store the result somewhere here. Now, what does composite take in? The first image and the second image. How is this being used again? Somebody had explained it somewhere here. The first image should be a constant value representing the masked off areas, and the second image is the original image. So the first image is supposed to be the green image. Oh yeah, this is supposed to be image dot from array numpy. Okay. The second image is supposed to be our original image, and this is supposed to be our mask. Now let's see what the result is. There's an issue with from array. Cannot handle this data type. 113. Is it expecting a flattened version? I think it's expecting a flattened version maybe. Okay. That didn't. Hold on. How do you. Okay, numpy array 123 and then 123. And then print c dot flatten. Let's comment all this out so there's no errors showing up. Okay, so that's been flattened. And that got flattened as well. Okay, so I don't think we should have an issue then if we create the array and then flatten it. Let me just confirm that that's the case. Yep, it's flattened. We should be good now. Wait a second. I didn't. Uh, okay, the truth value of an array with more than one element is ambiguous. Dude, what? I think I need to look at the documentation for composite a little more. Well, the composite documentation isn't really saying much. A is expecting, what did I store into A? A is a numpy array. I should be passing in the thing directly because that's a L mode thing. Images do not match. Images do not match. Okay, let's try printing them out. So we have green image dot size, I think. Yeah. Green image dot size. And then we have this. Okay. And then we have image array dot size. Let's print all of these out. Oh, it's because I flattened it. Was I not supposed to flat? Oh, yeah. I think I figured out that by default it might have been using a different mode. And then after that, I forgot to remove the flattening. Okay, have we fixed the issue now? Finally? Yes, I believe we have. Oh, okay, there it is. There it is. So the thing has been masked out there. Let's try changing. Um, is A being used after that? I don't think I need B or A for that matter. I think I can get rid of both of them and then just have this, right? Then I should be able. Oh, back up, back up. No. Let's create this. Okay, so then this becomes like a central location or the central variable that's going to be used. Okay. Uh, let's try changing the mask. What other masks did we? Oh, we can mask out the human. So that is what, 9, 8, 8. No, 0, 8 would be 9, so 7. Look at that, dude. Hell yeah. Hell yeah. Oh, you know what? I think I need to invert. Yeah, I think I need to invert the. How did I? So composite seems to be taking something out. Is it? No, because my assumption was that it would be putting. Wait, what is the value of green image? Or what does green image look like? Oh, that makes sense. Okay. So that's why it's looking like that. So composite is doing what it's supposed to. It's just that for some reason, for some reason, what I've given here is getting taken as blue. Let's try something else. Okay, so let's do this. Okay, the color changed, but something is off. Yeah, something is definitely off here. I need to look into this. But okay, that's gonna be it for today's stream. I don't think I'm gonna raid anyone today. Yeah, that's gonna be it. I'm gonna carry on with this. I'm just gonna relax for some time, and then maybe tomorrow I'll wake up and carry on with this. Zenar, thank you for stopping by the stream and hanging out and chatting, and thanks for the follow as well. Appreciate you hanging out. Anyone else who might have been lurking in the chat, thanks for hanging out. Uh, I think I'm gonna be streaming again tomorrow as well. Yeah, I'm just having a lot of fun with image segmentation. So I'm gonna try and write the logic to sort of bring all the masks together and create like a color mask kind of thing that I can overlay onto the original image. I'll find a good way to do that. I should also put that out there because I can write some very ugly code to do it, but like I would rather use uh, methods that are provided for those purposes, and I would rather do it in a way that's more scalable because I still have to do that thing that I wanted to do, which was iterate over all the files in a specific folder, and then generate the image segmentation maps, let's call them, for each image. We'll get to it. Eventually, we'll get to it. For now, I need to sort of, first of all, I need to sit and relax for a bit. Um, but eventually, once I get back to this, I wanna figure out the logic behind the masking thing, or specifically overlaying an image on top of this. Once I figured that out, then I'll start putting all of the other pieces on top of this as well, and then we should be good. Then I can scale that up. But yeah, okay. That's gonna be it for today's stream. I hope you guys have a nice